the probability of a person running is 30 percentage. That means the probability of a person not running
Not
is
running 70%.
70 percentage. Now, if a person is running, imagine probability of him being fit is, let's say, 80 percentage, and probability of him not being fit
20%.
is 20 percentage. The person is not running, he, let's say, he is, the probability of him being fit is maybe like not running, still fit, maybe 40 percentage. Okay. And probability of not fit is 60 percentage. Is it okay, this table? Okay. Now, see, what is Bayes theorem, Bayes formula? This is a little tough to understand. See, because somebody is running, so, see, this is called unconditional probability. The one that is happening first is called unconditional.
Unconditional.
Unconditional probability. This is also unconditional probability. There is no conditions for it to happen, right? Either you are running or not running. Then, if you are running, you are fit. Then this fit, you will be fit only if you are running. Then this is called conditional probability, because in order to be fit, you have to run first. Conditional probability. So these all are conditional. If you are running, then you will be unfit also. So if running has to happen 30%, then only 20% unfit. So conditional. Okay, these are conditional. Okay. So now suppose, before we get into Bayes formula, let's find out something else. What is the unconditional probability of being fit? That is my question. What is the unconditional probability? Probability of
50.
being
So
fit.
52.
What is
So
the
52.
unconditional probability of being fit? So unconditional means what? Now, so that means it has to cover
All the conditions of
this
being
part,
fit.
okay, and this part. So now this fit 80% and this fit 20% will happen provided the running is happening. And this, in order to be this fit 40%, this running has to happen. So if I say this running and this unrunning, not running is happening, that means fit will also happen. That means you can be fit 80 percentage and 30 percentage, or
or
40 percentage
non-running and fit.
and 70 percentage. That means you run, you don't run. I'm covering what? Fitness. You
Yes, sir.
run, fit. You not run, fit. Shravani, you understood this?
Yes, sir.
Then this becomes what? Unconditional probability of being fit.
Probability of being fit.
So 24 percentage plus 7 is 28 percentage, which is what? 52 percentage. Okay. Now in the same way, pretty clear, right? Shravani, you understood this?
Yes.
Now in the same way, if I ask you, what is the probability of what is the unconditional probability? What is the unconditional probability of being unfit? Can you try? Unfit. Unfit as in not fit. Not fit.
48%. So
Okay.
so it will be just 1 minus 52, right? We can do it that way as well.
Yeah, that is also fine. But right now, let's go with the long cut only.
Okay, so
How much you said?
48, like 30% into 20%
Uh.
plus 70 into 60.
Shravani, you got the idea how to do this?
Yes. Yes.
How?
So we're taking unconditional into not fit, and
So you
then
tell me
not
the
running
number.
into
So tell me the number.
30% into 20%.
Good.
Plus 70% into 60%.
Unfit. Yeah. Right. So this is what says 3 to the 6 percentage, 7, 7, 6, 42.
42.
48. You could have also done like this 52, that means remaining is unfit. But let's go with long cut only this way because it is more important to practice.
Yes, sir.
Okay. Now this is so far I have not come to base formula. No, but you understood the unconditional, how to find out unconditional, because many times it happens, not necessarily that B is dependent on A. Many times A can be dependent on B, or vice versa, as in vice versa. Both are possible. Okay.
Yes, sir.
Yeah. Now Bayes theorem is, or Bayes formula says this one only. That Bayes formula says, now here in this case, B is happening given A happens. This is written like this. B is happening given A happens. Okay. And this is probability of A. And this is probability of B given A. Given A means it is written like this, divided A. That means given A. So, and the joint probability is probability of A intersection B. This is the joint probability. Okay. So now probability of running happening first and then fitness happening second, joint probability is 24%. Or probability of fitness happening first and running happening second, still it will come to 24% only. Joint probability will remain the same.
Yes, sir.
Okay.
Yes, sir.
So now here the formula is what you know. Now here comes Bayes formula. Bayes formula says I will make this conditional as unconditional, and I will make this unconditional as conditional. That means now this I will make this unconditional as conditional, and I will make this unconditional. I will make unconditional. I will make conditional unconditional, and condition unconditional. I will make conditional. That means this one I will make conditional. So probability of A by given B. So if B happens first, then what is the probability of A happening? That means if fitness happens first, what is the probability of running? You got the question?
Yes.
Okay,
Yes, sir.
so now the formula is what, the formula is okay, probability of A by B is uh, okay. Uh, Here denominator is unconditional probability of B. I will make this second part as unconditional. So probability of fitness is what now? Probability of fitness is 52%, right? So unconditional probability is what? 80% into 30 percentage. Just I'm copying this part.
Plus
Plus 40% into
40 into
70%.
70.
I'm deliberately writing like this all instead of directly writing 52%. Okay, why? Because you will come to know now. This is one group and this is one group. Okay. Now the denominator is now see let A happen first, running happen first, or and then fitness happens. The joint probability is 24. Or let fitness happens first and running happens. The joint probability is going to be 24 only. So that means the joint probability is what? 24 only. So 24, that 24 is what? 30 percentage and 80 percentage. 30 and 80. So that 30 and 80 percentage will come in the numerator. You write as 30 into 80 or 80 into 30, doesn't matter. Okay. So this is the joint probability. Okay. So now this 7, 8, 3 are 24 percentage divided by this is 52 percentage. Just calculate this. Just calculate 1 minute. I'll be back.
0.46. इसका 0.46 आ रहा है क्या?
Yeah, 0.46.
Okay. Your exam is in February or May?
Feb.
Feb.
When is yours?
November.
Yeah.
0.46.
0.46. That means 46 percentage. No?
Yes.
Now, have you understood this formula? Okay, let me try to explain this. See, probability of so basically it works like this. Let's say,
So we are making the conditional probability unconditional,
huh,
and we are making the unconditional one conditional.
huh, yeah.
So I didn't understand the numerator part. Why is it again 18 to 30?
Um, okay. See, uh, probability of initially this is probability of A intersection B is equal to probability of A intersection B is equal to probability of A into probability of B by A.
Okay.
Right? Probability of A and then probability of B given A.
Okay.
So probability of A, okay, and into probability of B given A. Okay.
Okay.
So this is one part. Now probability of A by B is equal to, on this basis, or I can even say, see, probability of A intersection B is equal to, this step is okay, this step is fine.
Yes, sir.
Now I can also say probability of, B intersection A. That means both are same only, A intersection B or B intersection A. I can say probability of B, because this time B is happening first,
A
and then
by B.
probability of A given B. This is okay.
Yes.
So now, so you can imagine this, right? What I have written now.
Yeah.
Okay. So I'll just shortly write like this here. So this is probability of A, this is probability of B by A, and this is probability of A intersection B. I can write like this, or else I can also say probability of this is B, and this is probability of A by B. Okay. Probability of A by B, and then this joint one is probability of A intersection B. Finally, the total will remain the same, because let this action happen first and second action, or let second action happen first and first action. Total probability will remain the same. Okay, this is okay till here what I have written.
Yes.
A by B I am writing, or I'll write B by A. It's one and the same. I mean B intersection A and or A intersection B. So this is what I have written. So on this basis, I can say, so left hand side and right hand side all are equal only. Okay. Now what I want is probability of B by A. This is what I want. Probability of, sorry, no, what I want is A by B. This is what I want, right? This part, second part, not the first graph. I want the second graph. Probability of A given B, because B is happening first, no? So probability of A given B is this part. So I can say probability of A given B, this part. So probability of A given B is equal to probability of B intersection A divided by probability of B. This step is okay.
Yes.
Now probability of B by B intersection A is also equal to this part. Right? B intersection
Yes.
A is also equal to this part, no? Because
Yeah.
this is equal to B intersection A only. So I can write here as probability of B, and here numerator I can write as probability of A into probability of B by A. Probability of A by B is equal to probability of B into probability of B by A. Is this step okay?
Yes, sir.
This step is okay, fine, right? So now this is unconditional probability of B. So unconditional probability of B is something that we are getting from here, 52%, which is what, 80 into 30, 40 into 70. 80% into 30 or 40 into 70. Okay. And numerator is what? Numerator is probability of, this is a joint probability. The joint probability of A and then the second one. So probability of A is 30%, and the second one is 80%. So total is 24%, which I can write as 30 into 80. So the 30 into 80 is this one. So it will always be from this answer only, from the denominator only it will come up. Okay. It will always, it will always come up from the denominator only. So this will be 24% divided by 42%, which is what, 46. Sorry, this is 52 denominator, which is 46%. Okay. Now let me tell you the shortcut way also. This is just derived because you said you did not understand. I was deriving all this. Now shortly, if I tell you, okay, I'll draw this graph again. So probability of running, not running 30-70. So this is the original question. Running 30, not running 70. Then probability of being fit is what? 80, 20, 40, then 60. 80, 20, 40, 60. 80, 20, 40, 60. So probability of fit and not fit. Probability of fit and probability of not fit. So now when I want to know what is the probability of being fit, that means I'm making fitness unconditional. No, what is the probability of running given you are fit? That means you are already fit, I'm saying. So that means fitness will come as the unconditional. What is the probability of running given you are fit? So all you have to do is, given you are fit, the denominator will be unconditional. So unconditional is what? So unconditional will be this entire thing as well as this entire thing I will take. Both the sides fit I will take. So it is 30 into 80, 30% into 80%. Okay. And plus 70% into 40%. Is it okay? Denominator. Numerator, all you have to do is what is the probability of running, right? So running, I will take this entire joint probability. So 30% into 80%. Is it okay?
Yes, sir.
Okay, which is 24% divided by 52%, which came to how much? 46%. Now next question. What is the probability of running given you are not fit? So you are not fit is what? Unconditional. So unconditional probability of not being fit is what here? That means this one, and this one. Fine, okay.
Yes.
So not fit. So this will be 20. So I'll write it here itself. It will be unconditional. No? Unconditional, it will be 20% into 30% plus 60 into 70. Okay. And in the numerator, the question is what is the probability of running? So running is what? This one. This joint probability I will take, which is 20% into 30% into 20%. And whatever answer comes, that is it. Fine, okay.
Yes.
Now another question. So this is for second one. Second question. Then third question. Third is what is the probability of running? I said fit unfit. Okay. Now, what is the probability of not running? Given you are fit. Given you are fit. What is the probability of not running given you are fit? So given you are fit is what? Unconditional. So fitness unconditional is what? This part and this part. So 30 into 80 divided and then 70 into 40. Okay. So 30 into 80 or 70 into 40. It's white color. And then not running, probability of not running. So not running will come here. So 70 and 40%. So this is here.
So 0.538.
Okay, denominator is what? Denominator is 24 and
24 plus 28, 52.
how much?
0.538.
So 53.8%.
8%.
Okay. The next one. What is the probability of not running given you are unfit?
Unfit. Okay.
So given you are unfit. So unfit is the unconditional. So unfit means which one I will take? This one and this one. So 20 and both are 20, right? So this is 30. So 20 into 30%.
87.5%.
Plus
70 into 60.
60 into 70. Yeah, 70 into 60.
Yeah.
60% into.
So and the numerator will be 60 into 70 only, right?
Yeah. Not running. So not running will be.
So the final answer
Not
is 87.
Not running is this one, 60 into 70.
87.5.
Yeah. So finally, how much is it all coming to? 7 6 are 42% divided by this is 6 7 48%. How much is it coming to? %42 divided by 48. How much? Hello?
Sir,
Hello?
87.5.
Fine, you understood this one now?
Yes, sir.
Yes.
Base